Welcome to the deep dive. We're super thrilled you are joining us today to unpack all of this.
Survey considerations. SBP Polarity.
Yes, SBP stands for Sub-Bottom Profiler. We're moving past where the sound wave is and getting into the physical physics of the sound wave bouncing off the mud.
This is where it gets really deep.
The hardware manufacturers, Kongsberg and EdgeTech, regarding polarity at the seabed. The system uses the SEG standard, meaning the seabed gets a negative polarity because the acoustic impedance is changing from low to high. In seismic data, positive impedance contrasts must have positive polarity.
The negative polarity interpretation is causing the given envelope to lose resolution.
Okay, this is a heavy physics dispute. Let's break down the mechanics here. What exactly is acoustic impedance, and why does a sub-bottom profiler even care about it?
So a standard multi-beam sonar uses high-frequency sound to bounce off the surface of the seabed to make a topographic map, right?
Right.
A sub-bottom profiler uses lower-frequency sound pulses designed to actually penetrate the mud and sand, reflecting off the geological layers buried beneath the seafloor.
Like hunting for buried pipelines or rock strata or hazardous shallow gas pockets.
Exactly. Now, acoustic impedance is a physical property of a material. It is a material's density multiplied by the velocity of sound traveling through it.
Oh.
Water has a relatively low acoustic impedance. Saturated mud has a higher impedance. Solid bedrock has a massive impedance.
So when the sound wave travels through the water and hits the mud, it hits a boundary where the impedance suddenly increases.
Yes, that is a positive impedance contrast.
Here's where it gets really interesting, though. If you imagine bouncing a tennis ball off a mattress, that's the mud, versus bouncing it off a concrete floor, that's the rock, the physics dictate how much of the sound energy bounces back to the submarine, right?
Yes, and how much penetrates deeper. But the dispute here isn't actually over the physics itself. It's over the cartographic representation of the physics.
The graphing of it.
Polarity is the mathematical convention used to graph that returning sound wave on an analyst's screen.
Right.
When that sound wave hits the mud and bounces back, do we draw the spike on the graph going up into positive numbers or going down into negative numbers?
SEG standard, claiming a low to high impedance change dictates a negative polarity. You draw the line down.
Reading the rule book backward, they argue that a positive impedance contrast should yield a positive polarity spike. You draw the line up.
But this isn't just an academic debate over aesthetics, is it?
Not at all. The wrong polarity causes the given envelope to lose resolution.
Explain the envelope for us. How does a graph line going up instead of down destroy the resolution of the data?
When analysts look at sub-bottom profiler data, looking at raw oscillating sound waves is incredibly difficult for the human eye to parse.
Right, it just looks like static.
Exactly. So the processing software draws a mathematical envelope over the sound wave. It traces the absolute magnitude of the peaks, smoothing the high-frequency oscillations into distinct, visible bands that represent the layers of the seabed.
Okay, I'm with you.
If the software is programmed to expect a positive peak at a hard boundary, but the data feeds it a negative trough because of the polarity convention, the phase inversion confuses the smoothing algorithm.
Oh, wow. So the sharp, distinct line of a buried pipeline suddenly smears out.
The resolution blurs. And in this industry, a blurry map is a dangerous map.
Because if the polarity is flipped, a hard steel pipeline buried in the mud might look like a soft trench.
Or worse, a highly pressurized pocket of shallow gas, which has a very specific negative impedance contrast, might be misidentified.
But if they bring a drill ship out and drop a multi-million-dollar drill string onto a gas pocket they thought was a rock layer,
you have a catastrophic blowout.
the stakes are immense.
Yeah.
Lacks confidence in the resolution due to this polarity envelope issue